Hello everyone. Uh, this is my lecture number 20 on network theory. Today's topic is two-port network. For our motivation, Thevenin and Norton equivalent circuits are used in representing the contribution of a circuit to a specific pair of terminals. That means one complete linear bilateral network can be represented by a voltage source in series with resistance, that is the Thevenin equivalent circuit, and for Norton's equivalent, that is a current source in parallel with a resistance which is connected to a load resistance. So we are converting that total network into a one specific pair of terminals. So usually a signal is basically fed into one pair of terminals, that is input port, processed by the system, then extracted at a second terminal or second pair of terminals or output port. So it would be convenient to relate the VI response at one port to the VI response at the other port without knowing the element values and how they are connected inside the black box. So using that point, we can define a single port circuit. A port refers to a pair of terminals. Now we have here a pair of terminals, so two terminals. If we connect these 2 points, then we will have a closed circuit. Okay, so a pair of terminals through which a single current flows. So and across which there is a single voltage. So only current I flows and I come back, and there is a voltage across this terminal is V. Now externally either a voltage or current could be independently specified while the other quantity would be computed. I mean, if you connect a voltage source, you can measure the current. You can connect a current source, you can measure the voltage. The equivalent, the Thevenin equivalent permits a simple model of a linear network regardless of the number of components in the network here in the black box. So this is for the single port circuit. Now what is a two port circuit? A two port network requires two terminal pairs, that means total four terminals, so 1 2 3 4, and among the two voltages and two currents shown. So at this side, say this is input side, we show this is a voltage V1, current is flowing I1, there is a voltage V2 at the output side, the current is I2. Okay, now generally two can be independently specified. Okay, now how many distinct pair of independent quantities are possible? So in that case, that will be 6, 4C2, the value will be 6. Now by convention, regard port 1 as the input and regard port 2 as output. Port 1 as the input and port 2 as the output. We consider circuits with no internal impedance independent source. That means in this network we don't have, or we should not have, any independent source. Okay. Now some motivating examples. Now we can have circuit like a T like structure, like a circuit. We can have this is input side, output side. For transformer like circuit, input and output, two port system, and a analog circuit where we have, say, input we are giving here, we're taking output from here. Okay, and we can have this is for, say, op amp, and this is for, say, transistor. We can have two port system. So these are the motivating examples. So keeping this in our mind, we can find how to analyze the two port network. Now how to model the black box. That means, say, this is the two port network where we can have a source and we can have a load. Okay, source can be a CD player, load can be a speaker. For an example, we will see that a two port circuit can be modeled by 2 cross 2 matrix to relate the VI variables, where the four matrix elements can be obtained by performing two experiments. That means if we have a V here, we are applying V. If we short this part, output part, then we can find out the response current. Okay, or again you can connect a voltage source here, measure the current here. So we can do the experiment and we can find out the other parameter values. Okay, so now how to do that? For that we have to know the two port network modeling. Now no energy should be stored within the circuit, no independent source within the circuit, Now each port is not a current source or sink. That means this I1 current which is entering, I1 dash leaving here in this terminal, both should be equal. Similarly, I2 say entering, I2 dash is leaving. That two current must be internal equal, must be equal, and there should be no interport connection. That means between A and D, A and C, B and C, and B and D, there should not be any connection. Now, the two-port model is used to describe performance of a circuit in terms of voltage and current at its input and output ports. The two-port circuits are useful in communications, control system, power system, and electronic systems. Now, there are total 6 type of parameters, two-port parameters are there. Those are Z, Y, H, G, transmission line parameter, ABCD, and inverse transmission parameter. Total 6 parameters. Now, in that case, first one, let us take the example of Z parameter, which is also called impedance parameter. Z is the impedance. Now, here the main equation that follows in terms of Z, that is V equal to IZ. Okay, so two-port network we have V1, V2, I1, I2. Okay, so V1 is written in terms of IZ. Okay, plus I2 current with that Z. Okay, so V equal to I1 plus I2, V2 equal to I1 plus I2. That here V1, V2 are the dependent variables, I1, I2 are the independent variable. So V1 is nothing but I1. Here it is Z11 is the parameter. Here it is 1, 2 because this is 1 and I2 is 2, so it is 1, 2. For V2 it is I1 Z21 because V2 is here and I1 is here, and this is Z22 V2 I also 2. So the subscript using if you know this subscript 1 1, this should be 1 1. This subscript, the subscript is 1 2, so it should be 1 2 2 1, so 2 1 2 2, so that will be 2 2. So that is, you can remember like that way. Now you can write this in matrix format, that is v1 by v1 v2, z11 z12 z22 z22 21 22 and 1 I1 I2. Now to find out this z parameter value, what we can do is we can make other parameter equal to 0. That means if you want to find out z11, if you make I2 equal to 0, I2 0 means output port is open circuited, then we can find out v11, that will be equal to, you can find out z11, that is equal to v1 by I1 when I2 equal to 0, and when I2 equal to 0, z12 equal to v1 by I2 when I2 equal to 0. Okay, v2 Z12 equals to V1 by I2 when I1 equal to 0, and for I21 when I2 equal to 0, Z21 equal to V2 by I1, and when I1 equal to 0, Z22 equal to V2 by I2. So now in here what we can say, that here current, output current is open circuited, output port is open circuited once, and again input port is open circuited once. So to find out the parameters, Z parameter value, what we are doing, we are making the input and output port both open circuited. That's why it is also called open circuit parameter or Z parameter. Now this is the Z V1 by I1, that is nothing but V1 is the input port, I1 is the input port, so this is input impedance Z11. Now Z22 is V2 by I2, V2 is the output port, I2 is also for output port, so Z22 is the output impedance, and here Z12 is V1 by I2, so this is the transfer of impedance V1 by I2, so it is called trans impedance. Okay. Z21 also it is called trans impedance. Now according to that Z parameter equation, we can draw the equivalent circuit. Now this is the voltage equation. So what we have, I1 V1 is nothing but I1 into Z11 plus there is a voltage, controlled voltage source value Z12 I2, because here I2 is not flowing, I2 is at this output side, so we can have a dependent source here. Similarly, V2 equal to I2 into Z22, and we have a dependent source which is Z21 into I1. Okay. So as we are open circuiting the port, I2 equal to 0, I1 equal to 0, that's why it is also called open circuit impedance parameter. Now say for an example, now say this is a circuit, you have to find out the Z parameter. Now we can write the simple KVL equation. So V1 is nothing but I1 Z1 then plus Z3 into I1 current is flowing this way, I2 flowing this way. So I here at Z3 that will be I1 plus I2. So Z3 into I1 plus I2. Then we can find out I1 as a common factor. Then V2 equal to what? Nothing but Z2 into I2 and I1 into I1 plus I2 into Z3. Okay. Then you can find out into this equation in the form of V1 equal to I1Z plus I2Z, V2 equal to I1Z plus I2Z. So we can find out the Z1 Z parameter values. Now say one problem. Say this is a circuit, you have to find out Z parameters. Now this is the Z parameter written in matrix form. Now by definition Z11 is nothing but V1 by I1, okay, when I2 is 0. So when always you have to take care of this part when I2 equal to 0. Now if I2 equal to 0, no current is flowing through this path. Okay. Then V1 by I1 will be equal to what? That is Z11, that is equal to that no current is flowing here. So I1 current divides and flows through this path. So 15 plus 5 in series 20 parallel 20, that will be your Z11. So you can find out. Now next the parameter says Z21, that is V2 by I1 when I2 equal to 0. Now when I2 equal to 0, if you want to find out Z21, I2 equal to 0, then we can, if I2 equal to 0, then V1 equal to what? V2 equal to what? V2 equal to nothing but this is across this point is V1. So V1 divided into these two resistors. So that will be V2 equal to nothing but 15 volt, 15 ohm divided by 20, 15 plus 5 into V1. V1 is here across this 20 ohm. So we got V2 equal to in terms of V1. Now we know V1 by I1 equal to 10 ohm, that is Z11. So we can find out I1 equal to V1 by 10 ohm. Now this Z21 is V2 by I1. Now we can put this I1 value here. Then we got the value of Z21. Now Z22 is what? V2 by I2 when I1 is 0. Now when I1 is 0, that means what? This I2 current flows through this 5 and 20 ohm resistance in series and then it is parallel with 15. So their output impedance will be what? 20 plus 5 parallel with 25 parallel with 15. We got the value. Now Z12 is V1 by I2. Now, when I1 equal to 0, when I1 equal to 0, what will be the V1 here? That will be V2 divided into these two resistance. So that is 20 divided by 25 into V2. So you got that particular value. Okay. Now V2 by I2 already we found out the value. So I2 equal to V2 by this value. So that we can put it here. So Z12 is nothing but V1 by I2. So I2 we can put it here and we can find out the value. V1 we can write as in terms of V2 and I2 it is in terms of V2. So V2 V2 cancel out, so you get the Z12 value. Now say Y parameter, that is called admittance parameter. So admittance parameter means if you want to write an equation in Y parameter, that will be I equal to Y's V. So here that form is I equal to Y V. So here I1 I2 is the independent variable, dependent variable, v1 v2 are the independent variable, and we can have this y parameter values y11 y12 y21 y22. Okay, that is the admittance parameter that we can write in matrix form I1 I2 then y parameters value v1 v2. Now in this case to find out the value of y11 we have to make v2 equal to 0. If we make v2 equal to 0, then y1 equal to y11 equal to I1 by V1 when V2 equal to 0. Now when V2 equal to 0, we can find out y21, that is I2 divided by V1. Now to find out y12, we have to make V1 equal to 0, then y12 equal to I1 by V2. Similarly, y22 equal to I2 by V2. Now here we can see this is the Y11 is nothing but I by V. I by V means it is admittance. So this is port 1, port 1. So this is input admittance. Y22, I2 by V2. For port 2, we can say output admittance. I2 by V1, I1 by V2. So in that case, these two are the trans admittance. And you can see here what we are doing. We are doing V1 equal to 0 or V2 equal to 0. That means we are short circuiting the input and output port. That is why it is also called short circuit parameter or admittance parameter. And Z parameter is open circuit, because there we are open circuit the input and output ports. Here we are doing short circuiting. So using admittance parameter, we can find only the impedance value, or using Y parameter we can find out only the admittance parameter. Input admittance, output admittance, or input impedance, output impedance, or transfer impedance or transfer admittance. Now, according to this particular equation, we can draw the equivalent circuit I equal to YV. So, I1 current flowing, I1 into V1 here, and here this is V2. V2 is out at output side, so we can replace it by a current voltage controlled current source. Okay, so this is nothing but voltage control. V2 is the controlling part, and this is a current source. Voltage control current source. And for next, that is I2 into V2, I2 equal to what? Y21 into V1. Okay, that is the voltage control current source, and Y22 into V2, that is the I2. Here this, so this part is nothing but Y22 into V2. Okay, one current, another current is, because I equal to YV. Okay, and this is nothing but a voltage control current source. Okay, so as we are making V1 and V2 0, so we basically called it as short circuit admittance parameter. Now say this is a circuit pi network. In previous jet transfer example, what we have seen, this is a for a T network. Okay, so say to find out the y parameter values, we have to write the equation. So y I1 equal to what? Nothing but this current through this, that is V1 into Ya, and here current is what? V1 here, V2 here. So V1 minus V2 into Y. Okay, current is actually what? V minus V divided by R. 1 by R equal to Y, so V into Y. Okay, so we can find out in terms of V1 and V2 the expression. For I2, similarly, that will be V2 into YC and V2 minus V1 into YB. So we can again find out in terms of V1 and V2, then we can get the value of admittance parameter. Now, say for this particular circuit, now this is a simplified model of field effect transistor. Okay, GMV1, we have the capacitance value and output impedance or admittance value Y2. Now, using, if we apply KCL at point 1, what you can write? I1 is nothing but this current and this current. Now, this current is what? Nothing but this is the voltage across is V1 into SC1. Now, actually that will be what? V1 by XC. Okay, or in now in that case this will be S into C1. Okay, because it is nothing but we have to take the Y, not the X. We have to take Y. That will be V1 into SC1. Now here the current is V2 minus V1, or say V1 minus V2. V1 here it is V2. So V1 minus V2 into SC3. We can now rearrange that in terms of V1 and V2. For I2 also we can write is here V2 into Y2 admittance value. Okay, and here this for SC1 SC3, what is the happening is XC is 1 by SC1, or XC is 1 by SC3 for that C3. That means that is the impedance. Admittance will be SC1 and SC3. So that part where is that concept we have to use here. Now here the current is one. This is one current. This is another current. Another current is this one. So we have three currents here for I2 at this particular node. Okay, so that here this addition of GM V1 current, and here that is V2 minus V1 into SC3. Okay. Now we can find out in terms of V1 and V2, then we can get the admittance parameter values. Now, say Y parameter example. Okay. So this is a circuit. We have independent source here, dependent source here. Then there is no problem. We should not have any independent source. So you have to find out Y parameter. So this is the Y parameter matrix. Now, say to find out Y parameter, what we have to do is V2 is shorted. So V2 is shorted. Okay. Now I1 will be equal to what? Nothing but V1 into this is value is 40 by S. So that will be nothing but into S by 40. That is V1 into Y. Okay. Then in that equation V2 is 0. So this will be 0. Okay. So we got Y11 value as I1 by V1 equal to S by 40. Now I2 equal to what? Nothing but 3I1 this current minus I1. I1 plus I2 equal to 3I1. So I2 equal to 3I1 minus I1. So that is 2I1. I1 already we know. Okay. So that I1 value we can put it here. Okay. Then I2 by V1 that is equal to Y21. We got the Y21 value. Now for V1, so port 2 is shorted, port 1 is shorted. Okay. So short circuit V1. Now here what happened is I1 is nothing but V2, here it is V2, V2 into this into S by 40. This current is minus because we are taking V2 minus 0 into the admittance. Current direction is opposite, so minus. So y I1 by V2, that is nothing but y12 is, we got that value. Now for this particular node again, I2 is nothing but 3I1 minus I1 plus another value is there, there is a resistance which is nothing but V2 by 10. Now here that part is not there because this is shorted, because it is in parallel with a short circuit. Now if we solve this, we will get the value of Y22. Now say H parameter or hybrid parameter. Now this is a two-port network can be represented using the H parameter, which is described as in case of Z and Y parameter. For Z parameter it is written in B equal to IZ format, and for Y parameter Y equal to I equal to YV format. Now here it is called hybrid parameter. Here the independent variable is V, dependent variables are V1 and I2. V1 for port 1 and I2 from port 2. So V, how we can write, and the independent parameters are I and V2, I1 and V2. Now how we can write that? That is V1 equal to H11 into I1, again H12, so this V1 and V2, so H12, I2 equal to H21 because here we have I1, and here H22 because that is I2 and V2. So this is the H parameter model. Why it is called H parameter? Because here we have both V and I, okay, in that equation. In previous, in Z parameter, the equation is written in only in V equal to Y IZ format, and Y parameter I is written only, but here we have mixture of V and I. And another point is there, this is the corresponding matrix form, and to find out value of these H parameters, H11, whenever you have to find out, you have to make V2 0. Now if you make V2 0, H11 is V1 by I1, okay, and I H21 equal to I2 by I1 when V2 is 0 for this case. When I1 is 0, we can find out H12 which is V1 by V2 and H22 which is I2 by V2. Now looking into this, but these four expressions, what we can see here, either we are making V2 equal to 0 or we are making I1 equal to 0. That means we are short circuiting the output port, so V2 equal to 0, and we are making open circuiting of input port. We are making I1 equal to 0 to find out the H parameter. So here we are doing both, either short circuit, we are doing both short circuit of output port and we are doing open circuit of input port. So that is why it is called hybrid parameter. In case of impedance and admittance parameter, we are doing either short circuiting, okay, for, or either open circuiting. For Z parameter, that is in case of V equal to IZ format, okay, that means we are doing open circuiting. For admittance parameter, y equal to I equal to yv format, so we are doing short circuiting. But here we are doing open circuiting and short circuiting both. Okay. Now here it is called v1 by I1, that is why this is called input impedance. Okay. Now H22 is I2 by V2, that is nothing but output admittance. I by V is admittance. Now here it is called H21, I2 by I1. I2 by I1 means it is called forward current gain. And here H12 is V1 by V2. It is called reverse voltage gain because it is 1 by 2. If it is V2 by V1, then forward voltage gain, just like this one. So in using H parameter, we can find out input impedance, output admittance, forward current gain, reverse voltage gain. So we can find out current gain, voltage gain, input impedance, output impedance or admittance, all the values. That is why this H parameter is used in electronic circuits. Okay. Instead of finding out only the impedance and admittance, we can find out the voltage gain and current gain also. Now, to represent that in equivalent circuit, V1 is nothing but summation of the voltage sources. So this is I1 into H1 and H1 to V2 is the voltage control voltage source. And here this is current. So here there should be current, and current addition is possible in parallel branch, voltage addition in series branch. Okay. So this is I2 equal to what? Nothing but V2 into H2. So this is V2 into H2, and here this is the current source, which is current controlled current source H21 I1. So as we are doing short circuiting and open circuiting, that's why it is called hybrid parameter. Okay. So voltage is added in series, current added in parallel. Similarly, if you see here, uh, this is current value, so both are in parallel, you have to add. And if in case of Z parameter, this is voltage equations, so this is add in series. Okay, so these are the basic concepts that you have to remember always. Now say H parameter example, using a transistor we can model that in using H parameter. That means this is a nonlinear device is modeled by a linear type of circuit. Okay, so that you can analyze it. So this is your input impedance, this is your voltage, I mean dependent source, okay, with reverse voltage gain, and this is your current gain into IB base current, and this is your collector current IC, and this is your admittance, okay, output admittance. So this is how we can make it the model of H parameter of a transistor or BJT. Now H parameter of a BJT, so say this is Z1, beta I1 and Y2. Now here what we can write, that V1 equal to I1 Z1, okay, and I2 equal to summation of these two current beta I1 plus Y2 V2. So we can find out H parameter value directly. Here it is plus, nothing is there, so it is 0. The same problem that we did for this Y parameter, we can solve it by H parameter also. Now this is the H parameter model. What we are doing for that, we are making V2 equal to 0. If we make V2 equal to 0, that means output port shorted, then we can find out H11 and H21. Okay. Now when output is shorted, I1 is nothing but this voltage V1 into 40 by S by 40, okay, into impedance admittance, so 1 by 40 by S, so S by 40. So we can find out V1 by I1, which is 40 by S, that is your H11. Similarly, I2 equal to what? Nothing but 3I1 minus I1. This resistance is shorted because this is in parallel with short circuit. So minus 2I1. Now I1 I2 by I1. So V2 0. So I2 by I1 is H21. So I2 by I1 equals to 2. That we got the value. Now we are making port 1 as open circuited because we have to make this I1 equal to 0. If we make I1 equal to 0, we can find out this H12 and H22 value. Okay. I1 0 means this current is 0. Okay. So what we can write, this V1 equal to V2. Okay. And H12 is nothing but V1 by V2. So if you do V1 equal to V2 from this particular circuit, so H12 equal to 1. Now V2 is equal to what? Nothing but 10 into I2. Okay. V2 equal to 10 into I2. Drop across the resistance. So V2 by I2 is the I2 by V2 is the H22. So I2 by V2 is nothing but 1 by 10, that is 0.1. So this is how we can solve it. So always try to remember the point that how we are getting making the other port short circuiting or open circuiting. According to that, you have to calculate. Now G parameter is nothing but the inverse of H parameter. In case of H parameter, we have taken V1 and I2. Here we are taking I1 and V2 as dependent variable. So independent variable will be opposite of that. That is V1, I2, and we have the G parameter, and this is the expression. So using G11, when we make I2 equal to 0, G11 is I1 by V1. So this is input admittance. Z21 is V2 by V1. So this is forward voltage gain. And Z12, when we are making V10, so Z12 I1 by I2. That means this is reverse current gain, and G22 is V2 by I2, which is nothing but output impedance. So using this is almost like H parameter, but we are getting inverse of that. Okay, and these are the conversion from this G parameter to Z, Y, and H parameter. Okay, so now there is another type of parameter that is there. That is called transmission or ABCD parameter. In this case, the main problem is, in other cases we have this current I2 is entering into network. This is transmission line, so it is basically one-way direction. Okay, so we can consider the current is outgoing, not incoming. So V1, in case of transmission parameter, we have to write in terms of V1 I1. That means it is written in same port, not the different port. So V1 is nothing but AV2 minus BI2 CV2 minus DI2. Now here why I am minus? Not because we are assuming current is going away, but actual network we have to consider it is entering. Now if we want to find out, now in this G parameter also we are making V1 as short circuit, output port as open circuit. So there is a hybrid type G parameter, inverse of hybrid, right? Now here V1 is nothing but V1 A equal to V1 by V2 when I2 equal to 0. That is open circuit reverse voltage gain. Okay. Then V is nothing but V1 by I2 minus I2 when V2 is 0. That means short circuit reverse trans impedance V1 by V2. C is nothing but I1 by V2. So it is when I2 is 0. So open circuit reverse trans admittance I1 by V2. And D is nothing but I1 by I2, I1 by minus I2. So short circuit reverse current gain. Okay. Now we can have inverse transmission parameter. In we have considered V1 I1 here, but for inverse transmission parameter we have to consider V2 I2. Then we can write in terms of V1 I1 instead of writing A B C D, A dash B dash C dash D dash. Okay, then we can find out the values of A dash, B dash, C dash, and D dash by making either I1 0 or V1 equal to 0. So what we are doing here, open circuiting and short circuiting the input port, and here we are open circuiting and short circuiting the output port. V as V2 and I2 is 0. So this is how we can remember this all these six eight parameters, two parameters. Now let us check one condition, that is called condition for reciprocity of a two-port network. Now reciprocity, already we have studied the reciprocity theorem. That means if the ratio of voltage at one port to the current at other port is same to the ratio if the position of the voltage and current source are interchanged, then the network is said to be condition for reciprocity of a two-port network. That means suppose we have applied a voltage source at input side, short circuiting that, so we get a current response. Now if you find out that Vs by I2, what is the value? And if you now after exchanging the voltage source, I mean voltage source at output port V2 and current is flowing is I1 dash, the ratio of this V2 is say Vs by I dash, I1 dash. If both are equal, then that is a condition for reciprocity. Now for that example, say condition for of reciprocity for z parameter. This is the z parameter equation in terms of Viz. Okay. If V1 is Vs, now we are making V1 equal to Vs and I2 is shorted here. So I2 is entering, so current is leaving. So I2 equal to I2 dash equal to minus I2. Okay. And V2 equal to 0 because we have short circuited that. Now if we want to put the value in the first equation, V1 is Vs and I2 equal to minus I2 dash. Okay. Again V2 is 0, second equation, and I2 is minus I2 dash. Then you got this equation. From this equation, you can find out what is the value of I1 in terms of I2 dash. That we can put it into this particular expression. Okay. Then we got this one, and if you calculate that from this, you can calculate Vs by I2 dash. So we got this Vs by I2 dash. Okay. This is the value. Now we have to do for this. This is for considering figure A. Now figure B, V2 equal to Vs. Okay, V1 is short circuited equal to 0 and I1 equal to I minus of I1 dash or I1 dash equal to minus of I1. Now we can put this equation into this first in V1 equation. So 0 equal to this particular, you can find out what is the value of I2. Okay. Now in second equation put V2 equal to Vs and I1 equal to minus I1 dash. After that we can put this I2 equation here, then we can find out Vs by I1 dash because we are here we will have only I1 dash. So using that we got Vs by I1 dash. Now we got Vs by I2 dash and Vs by I1 dash. If both are equal, then the two-port network is reciprocity. It follows the condition for reciprocity. So if we equate that, then what we see, if Z12 equal to Z21, then the two-port network or for Z parameter will become the reciprocal or satisfy the reciprocity condition. So condition for reciprocity of Z parameter, that is Z12 equal to Z21. Okay. Similarly, we can find out it for the Y parameter. So same thing we have to do. V1 equal to Vs, V2 0, I2 dash equal to minus I2. Put it into first equation. We get, and that is we get I1 equal to V2 is 0, so Y11 Vs, V1 equal to Vs. So again from second equation, minus I2 equal to V2 equal to 0, so Y21 Vs, V1 equal to Vs. So now Vs by I2 dash you can find out directly. Okay. Now V2 equal to Vs, we have to put it into that equation, and I1 equal to minus I1. So minus I1 dash equal to V1 equal to 0 that time. So V2 Vs into I12. So Vs by I1 dash we got the value. And if we equate these two, what we will get? If Y12 equal to Y21, then Y parameter to the Y parameter Y parameters of two-port network satisfy the condition of reciprocity. Okay. Similarly, for H parameter also we do the same thing. V1 equal to Vs, V2 equal to sorted, so 0, and I2 dash equal to minus of I2. Now, for that, we can put that into the first equation. V1 equal to Vs, V2 is 0, so H11 into I1. Now, for second equation, I2 is nothing but minus I2 dash. H21 into I1, V2 is 0. From here we can find out I1 in terms of I2 dash. That I1 we can put it in this equation. Then we can find out Vs divided by I2 dash. So this is the equation. Now we can do it again for say V2 is Vs, V1 is 0, I1 dash equal to minus I1. Put it into first equation. That will be V1 is 0, I1 equal to minus I1 dash plus H1 to Vs. So we can from here we can find out Vs by I1 dash. So we got this value. We have to equate both. Then what you will get here that H12 equal to minus H21. That is the condition of reciprocity of H parameters. Okay. Similar thing we can do it for ABCD parameter. That means V1 equal to Vs, V2 equal to 0, I2 equal to, here it's not minus, it will become plus because both direction will be the same. So we can put V1 equal to Vs and V2 is 0. So Vs by I2 dash equal to B. That we got directly. Now for say from second case, V2 equal to Vs, V1 0 and I1 equal to minus I1. Then that will be 0 Vs minus B I2 and another expression we got. Now we can find out I2 value from this equation that we can put in the first in this particular equation. Then if we solve we will get this expression. Now if we equate this particular Vs by I1 dash equal to Vs by I2 dash, then we will get AD minus BC minus equal to 1. So this is the condition of reciprocity of ABCD parameter. Now say condition for symmetry in two-port network. Symmetry means if the impedance measured at one port is equal to the impedance measured at the other port with remaining port open circuited, the network is said to be condition for symmetry. Now for symmetrical networks, both the port impedances must be equal. The impedances at two ports can be measured like this way, that we can find out this. We can connect a voltage source, okay, V1 equal to Vs, and this is output port is open circuited, okay, so current is 0, and or so we can find out this V1 by Vs by, we can find out this Vs by I1, and for second case we can connect voltage source V2 or Vs at output side and keep input side open circuited, find out the impedance, that is Vs by I2. If both are equal, then that is the condition for symmetry. So say for Z parameter, V1 equal to Vs, I2 equal to 0. Okay. So if we put it into first expression, then I2 0. So we get Vs by I1 as Z11. And if we put V2 equal to Vs from the second picture and I1 equal to 0, then what we will get Vs equal to Z22 into I2. So Vs by I2, that is equal to Z22. That means what? Condition of symmetry is Z11 must be equal to Z22. Okay. Now say for Y parameter also V1 equal to Vs, I2 equal to 0. Now we can put V1 equal to Vs here, I2 equal to 0. So that is the in second equation. From second equation we can find out V2 value and we can put into this particular equation. Then we can find out Vs by I1, what is the value. After that V2 equal to Vs, I1 equal to 0. Put in the first equation. So the I1 is 0. So from that we can get V1 in terms of Vs, and at the second equation put the V1 value, then we will get Vs by I2. Now if we equate the previous Vs by I1 with equate with Vs by I2, then if we solve it you can get that will be Y11 equal to Y22, okay, for condition of symmetry. Now condition of symmetry you can see that out input impedance should be equal to output impedance, admittance, input impedance should be equal to output admittance, okay. Now we can do it for H parameter also. V1 equal to Vs, I2 equal to 0. So we got two expression. From this expression we can find out V2 is in terms of I1, that we can put it in this equation. Okay. Then we can have Vs by I1 as the expression. Similarly, V2 equal to Vs I1 0. Put in the equation, we get Vs by I2. If we equate that, we will get condition of symmetry is H11 into H22 minus H12 into H21 equal to 1. That is the condition of symmetry for H parameter. Similarly, we can solve it for ABCD parameter. Okay, put V1 equal to Vs, I2 equal to 0 into the equation. Find out Vs by I1. We get Vs by I1. Next, V2 equal to Vs, I1 equal to 0. Put in that two equations and try to find out Vs by I2, that is D by C. So from this we can get the condition of symmetry as A equal to D. Okay, so we can find out condition of reciprocity, condition of symmetry of all the two-port parameters. Now say there are certain type of interconnections of two ports. That is, one is cascade connection. For that we have to use the ABCD parameter. It is direct cascade connection. Series connection also possible. That means now see here, this is the port. This is connected in series. Okay, and this is Z parameter is the better one for that. And parallel connection means this particular part is connected to here, this particular is connected to here, and first connected to this one, and this one connected to next one. That is parallel is better for H parameter. Series parallel. So first part is series connection, second part is parallel connection. Okay, that is H parameter is better for series parallel, and parallel series, that is first part is connected in parallel, first port, second port is connected in series. That is better for G parameter for analysis part. Now say for two port network, if it is series connection, okay, then so we have cascade, series parallel, parallel series. Let us take series example. Now series example, what we can see that it is the first port, now second net terminal connected to the first terminal of the second port of the input port, and output port also same thing. Okay, that is the series connection. Okay, so V1 is nothing but V1 plus V2 because this is connected in series, and V2 is nothing but V2 plus V2 prime plus V2 double prime. And here, as this is series, current will be same. So I1 equal to I1 dash equal to I1 double dash, I2 equal to I2 dash equal to I2 double dash. Then we can write this in terms of V1 prime, V2 prime, the expression V1 double prime, V2 double prime expression. Then we can add. So V1 is and V2 is nothing but V1 prime plus V2, V1 double prime. So that part we can add. Okay, then we can write in and I1 and I double prime equal to I1. So in terms of I1 I2 we can write that. Now what we can get is that it is the addition of the parameters. That means Z11 prime plus Z11 double prime, Z12 prime plus Z12 double prime, like that way. So this is the equivalent Z parameter if two networks in connected in series. Now in parallel connection, what happened? Parallel connection current will be add up, voltage will be the same. Now we can write these two expression of for two networks. Now we can write add up this current I is the addition here because parallel connection. So here we can find out after addition that y parameter is nothing but y11 prime plus y11 double prime, first network plus second network. Like that way you have to add. So for series connection, Z parameters will be added, parallel connection, Y parameter will be added. Similarly, cascade connection, what we can see, this is for ABCD parameter. Now here it is what this V1 equal to V1 dash and V2 dash equal to V1 double dash, V2 dash double dash equal to V2. Similarly, I1 equal to I1 dash minus I2 dash equal to I1 double dash and I2 equal to minus I2 dash. So we can write the for two separate network to separate equation. Now we have to write in terms of Vi equal to V dash I dash. Now Vi in terms of Vi I dash, that is equals to what? Vi I dash is nothing but this particular equation. So you can write it here. Now V2 dash equal to V1 double dash minus I2 dash equal to I1 double dash or I1 double prime. Now for this we can write in terms of this particular equation. So you can see this is the matrix multiplication. A dash, B dash, C dash, D dash, the one matrix. multiply with another matrix A double dash B double dash C double dash D double dash. Okay, so this is the way we can calculate the series, parallel, and cascade interconnection. Now say transformation between different sets of parameters. Let us take one example, H parameter to Z parameter. So we can write this H parameter equation, I mean V1 and I in terms of V1 and I2. Now from this second equation, what we can write that we can write V2, we can write that this part we can take from the left side, right, and we can write V2, okay, in terms of I1 I2, in terms of I1 I2. Now here y parameter, z parameter, you have to write V1 in terms of I1 I2, and we can equate that. So this particular term minus H21 H2 is nothing but Z11 and Z12 is 1 by H22. Now to find out the other two parameter, say in V first, from second equation we got the two values. Now in first equation we can put the value of V2 here. Okay, so this V2 value we can put it here. Then in terms of I1 I2 we have to write separate that. So we have to write V1. So from we got the value of V2 equal to what? So second equation, then Z1, Z21 and Z22 we got. Now we have to write an equation in terms of V1. So V2 value we have put it in here in the first equation V1, and we have written this V1 in terms of I1 I2. Now here del H is nothing but H11 into H22 minus H12 into H21, which is nothing but the determinant of H matrix, H parameter matrix. So according to that we can find out Z11 and Z12 value. Okay. Similarly, Y parameter value also you can find out. Say Y parameter means I1 or I2. Now I2 is written in terms of V1 V2. Okay. So from this equation, or I1 equal to V1 V2. Okay, any one of that you have to follow. Okay. Now what we can do is I1, okay, in terms of V1 V2. So we can write directly. So from this first equation, I1 equal to what? Nothing but this is V1 1 by H11 minus H12 by this. So first comparing this with this particular equation, what we got? Y11 equal to 1 by H11, Y12 equal to minus H12 H11. Now in that I2 equation we can put this I1 value into this I2 equation, and we can write in terms of V1 and V2. If you solve it, you will get the Y21, Y22 value. Here also we have this JLH value, which is nothing but H11 determinant of H parameter matrix. Now this is the two example that I have shown you transformation, and we can have other transformation also. So this is your Z parameter, this is your Z to Y parameter conversion, Z to H parameter, Z to ABCD parameter. Similarly Y to Z, this is your Y parameter, Y to H, Y to ABCD. So like that we can do this transformation. Now this you can practice, and you can do that yourself. So this is it for today, and this is all about the two-port network. Thank you so much.